Hey everybody, this is Alex Merced from alexmercedcoder.com with another video on Go programming. And today we're going to talk about one of the topics I used to really hate when I was learning C++, and well, now I get it, but it is definitely one of the trickier things to understand, and that is pointers. Okay, and so we're going to have a chat about that, and if there's time, maybe we'll do arrays, but I think for the most part we're going to be doing pointers in this lesson. Okay, so here's the idea. Okay, so let's say I create a variable. Okay, I create a variable, so we'll just say cheese equals Gouda. Okay, and let's say I make a function. So let me go to my functions package, functions.go, and we'll say func mu can I change string? Oh, it has to be capitalized so it gets exported. Can I change string? Okay, and we're going to pass in a string, and it will, well, I'm not going to return anything, so I'm not going to put anything. Okay, and what I want to do is say x equals provolone, and we will return x. So yeah, I do want to return a string, so let's specify that. Okay, so we have this function. I have made a variable called cheese. So let's see here. Function. Well, I want to print it. So print function dot can I change string. I want to pass in cheese into there. Okay, and then I will. Okay, print cheese. So the idea is I'm passing the cheese variable in there. I change the value of the variable, but as you'll see, technically when it gets passed into the function, the actual cheese variable doesn't. It's just a copy of it. So cheese will still be worth to have the same value. So let's run this. Let's hope this all goes well. Yep. So you can see I changed x was cheese, which was Gouda, but then I changed it to provolone, and I return it, yet the original cheese variable still remains cheese. Okay, so basically the way all functions work, when you're just dealing with your plain variable, you're just dealing with the value, and whenever you pass it into a function, the function only receives a copy of the value. But there's times where you would actually like to change the actual variable in the function. So how do you do that? Well, that's where pointers come in, where basically a pointer variable would equal a pointer variable equals basically literally a point. It points to where that specific information is in the computer's memory. So we're not saying, hey, we have this value of Gouda, okay, make a copy of it. We're saying this is the address where this value can be found if you want to use it. Okay, so what I want to do is make a pointer. So the way this would work, so we'll call this cheese p for pointer. Okay, and this is going to equal, we use the ampersand, which stands for the address of the data. So I'm going to say the address of cheese. So I'm not assigning the value of Gouda, I'm assigning the memory address to cheese p. Okay, so now let's print the value of cheese p, so you can see that it's not Gouda, cheese p. Okay, so that'll be first. Save. Let's run the thing. Okay, so you get this address. So see, it's where it's located in memory. Now, if I wanted to print out the value, then I would just use the asterisk. So whenever I use an asterisk here, it says it's really the value at the pointer's address. So in this case, this should technically print Gouda now. See, and we print out Gouda instead of the address. So now, if I do this, if I say the value at this address, cheese P, now equals American, and then I were to print, so now I let the rest of the function go the same way. So again, cheese starts out as a Gouda, and now when I print out cheese over here, it should turn to be American, because here, even though I didn't ever reassign cheese, I did do an assignment to that memory location, which does change what's there. So just to kind of illustrate the point. Okay, so see, it became American. So I can change, now I can change the value of cheese without having to worry about whether I have access to cheese. So now I can write my function in a way that actually changes cheese. So instead of saying, hey, I want to pass in a string as an argument, I'm going to pass in a pointer to a string value. Okay? And we are... Well, then I got to go over here and make sure that I'm changing the value at the address. Okay, and we can return X, but that doesn't really matter. Actually, I really want to return the value of X, not the address. Yeah, let's do it that way so we can see it's a pointer. So in that case, I want to return the pointer of a string pointer. So that should clear that up. So now when I run this function, we should get a different result, but I need to pass in cheese P, because cheese P is the pointer. Okay, so I pass in a pointer to a string value. And let's watch what happens. Okay, so see what happened was this function returned the pointer, the actual memory address. So that's why that got printed. But notice when we console log cheese, now it is provolone. We've actually changed the cheese. Cool. So now you can control when data gets passed in as a copy versus when it gets passed in by reference, which is what this is. So if you ever use like JavaScript, JavaScript does this by default. Like you don't get to choose when you do this and when you don't. Essentially, whenever you're working with like arrays and objects in JavaScript, it just automatically does it as like this, as a pointer, as a reference. So that's why you're actually able to manipulate arrays and objects inside functions, while single pieces of data are not mutatable in a JavaScript function because they're passed in not as a pointer, they're passed in as a value. In Go, any piece of data you can go either way. You can say, hey, we want to change it, we want to pass it in as a reference, or we just want to pass in a copy of the value. Whenever you want to pass it in as reference, that's when you use pointers. So again, when we're grabbing the address of an existing variable, we use the ampersand. Whenever we're looking for, whenever we have a pointer variable and we want to grab the value at that location, the address, we use the asterisk. Again, the value by itself is just the address. So, yeah, I'm going to leave it at that. That's a good piece of computer science thinking. But yeah, pointers are pretty much in any lower level language. So if you've done C++, if you've done Java, I assume pointers exist in Rust. I haven't done Rust yet. So that's what pointers are. Again, it just allows you to create a variable out of the memory location of the data, so that way you can have access to that data in places where the scope normally would not allow you to. Okay, so my name is Alex Merced from alexmercedcoder.com. Have a great day and enjoy.